This video is on limit laws in calculus, and I'm kind of going along with James Stewart's calculus textbook. This is chapter 2, section 3, which is called Calculating Limits Using the Limit Laws. This is the first of two videos over that section. Well, what are the limit laws? Well, in formal terms, basically, let's say that you're taking the limit of two functions that are added together. The limit of f of x plus g of x. So we've added f of x plus g of x, and then we've taken the limit as x approaches a of that sum. Well, the first limit law says that we could have just as well taken the limit of f of x as x approaches a, and taken the limit of g of x as x approaches a, and then taken that answer, what the limit turns out to be. We could have added the limits together, and we would get the same result as if we add the functions together and then take the limit of it. So the sum of the limits is equal to the limit of the sums, as it were. That's the first limit law. Second one's very similar. The difference of the limits, that's this side here, the difference of the limits is equal to the limit of the difference between the two functions. We can go either way. There's more than one way to skin a limit. Many roads lead to the same place. Here's another one. So the limit of a constant times a function is the same as that constant times the limit of the function. You can pay me now, you can pay me later. Doesn't matter which order you do them in, you're going to get the same result. Here's another one. Let's say we have two functions and we multiply them together. You can either take the limit of the one and the limit of the other and multiply that limit, those limits together, or you can multiply the two functions together and take the limit of that result. You're going to end up with the same thing. Finally, very predictably, if you have the quotient of two limits, the quotient of two limits is the same as the limit of the quotient. Again, and of course, the mathematicians of the world require us to say, as long as the denominator is not zero. So these are the first five basic limit laws, or to put them in everyday speak, the limit of a sum is the same as the sum of the limits. The limit of a difference is the same as the difference of the limits. The limit of a constant times a function is the same as a constant times the limit of a function. The limit of a product is the product of the limits, same thing. And the limit of a quotient is the same as the quotient of the limits, as long as the denominator doesn't equal zero. Okay, so those are some basic limit laws, the five most basic limit laws. We can, however, by extension, come up with six more. So since raising something to a power is the same thing as multiplying several times, we can say that the limit of a function raised to a power is the same as raising the limit to that power. So the limit of a function raised to a power is the same as the function, the limit of the function. Okay, so we can either take the function to the power and do the limit of it, or we can do the limit of it and raise that to the power. We're going to get the same result. The next two are pretty simple. The limit of anything applied to a constant is just a constant. I mean, that's what a constant is. A constant doesn't change. It's a number, like 7. The limit as x approaches infinity of 7 is 7. Because it doesn't have anything to do with what's going on with x's and stuff. It's just a number. It's a constant. So the limit of any constant is a constant. The same approaches here. The limit of x as x approaches a is it's a. Now the x here I have in mind is not a real complicated x. We'll get into complicated x's like polynomials. That's more than just a little dinky x. That's in the next video. But if you're just talking about a very simple x, the limit of x as x approaches a is a. Okay. The limit of x to the n as x approaches a is a to the n. Again, it's kind of a simple substitution going on in this particular case. Okay, now let's do roots. Roots are kind of like dividing over and over and over again in a way. And so the limit of the nth root of x as x approaches a is the same as the nth root of a. That kind of follows again. We're kind of, it's actually a version of number 9. And then finally, the limit of the nth root of a function is the same as taking the nth root of the limit of the function. Again, pay me now, pay me later. You can do these functions, these operations first and then do the limit, or you can do the limit of the components of the operation and then do the operation. No matter which order you do it in, it's going to come out the same way. And those are the 11 basic limit laws for calculus.